Mrs. Schaefer, I wanted to give you feedback on the 2.06 phase change lab. You are looking good. Almost got it there. I think there's some things we need to tweak in our understanding that will affect both this grade, which you can redo and submit for a better grade, and the Unit 2 quiz. So let's go through some of these things together. Many of you got this idea with the chemical change and the physical change right from the word well, and that's fine. Chemical change is about creating a new substance. Physical change is about changing some of its physical properties, but a new substance is not created. If you missed one or both of those, just fix it and turn it back in. The idea is that physical change, this process of phase change, trying to look at what's a physical change, what's a chemical change, and then applying it. So when we're talking about a phase change, in this case, like water in our experiment, when it goes from one phase of matter, from a solid to a liquid, is this a physical change or a chemical change? So the question is a new substance formed? Is a new chemical substance formed? So the chemical formula, does it change? And in this case, no, there's no new substance being formed because we know we can evaporate water and condense water and it's still water. So when it goes from solid, liquid, gas, back to gas, liquid, solid, those are just physical changes. No problems with the if-then statement. If heat is added to a system during a phase change, then what happens to the temperature? Increase, decrease, or stay the same? And then it's all about testing it out. So we have the data given to you. It was given in the student guide, but it's also in the instructions where you're filling in the state of matter. We also did this in class where we walked through it step by step in there. The big thing is to remember that by the end of the experiment, even though there was evaporation and the water was boiling, see right here it says all the water is boiling, that means it's in two states. There's liquid and gas because there's still liquid present. So if you want to check out and compare your data with the recording or with here, make sure you have that correct because then that will affect your graph. But most people really struggled with the graph and beyond. So I'm going to spend a little bit of time here. Remember, you've seen this graph before. The difference is this part of the graph we did not do in the experiment. Be sure that you get the title in there. That's worth 1 point. Then you're going to graph your data and label it. That means you have to have a key. You can have something as simple as this down here. There's other ways you can do it. This is just my example of I changed the shape and the color. You can just change the color, but it's labeled and I have it clearly showing. So I have ice, which is the solid phase, ice and liquid, which is a solid and a liquid phase, water, which is liquid, and the boiling water, which is liquid and gas. And that goes to match with my data right here. There I have it all lined up so I can make sense of it. So that's how I did this. And then I'm going to go in and graph it. This is another way that you could graph. Notice that they use the same shape and this time they just put text box over. That's still a key. So it still works. The big thing is to make sure you have a key because that's worth 3 points. So get that title in, make sure you have a key somewhere explaining it. We want you to see and know that you know this is ice. You know these points here are ice and water. And then we have this idea where this increasing slope is just liquid water. There's no ice anymore present. And then we have boiling water, which means it's in a liquid and a gas phase. We want you to see this. we're trying to really make sure we understand this graph, because there are many questions on that Unit 2 test that are tied to understanding this concept. And it also helps us really see some patterns in science. So question 6 asks, what happens, what do you notice about the states of matter when the temperature is constant? So here I have constant temperature 0, 0, 0, or constant temperature 100, 100, 100, 100. If I go over here to my data table, I notice that there's an and, liquid and gas, solid and liquid. So when the temperature is constant, there's more than one state of matter present. So when the temperature is constant, there's more than one state of matter. I see solid and liquid, and I see liquid and gas. Well, what happens when the temperature is changing? Well, there's only a couple places on my graph where the temperature is changing. I have right here, and then right here at the beginning of my data table, right there, and then right there. So what's happening in that spot? Isn't that interesting? Look at what I have. How many states of matter are present when the temperature is changing? Here's where a lot of people lose points, and they lose points not because they're not understanding the material, but because they didn't take the time to explain the data. We need to provide evidence. That's our job. So here's my example. My hypothesis stated that if heat is added to a system during a phase change, then the temperature, maybe I said increase. My hypothesis was correct or incorrect, because the data from the table shows me that at the constant temperature of 0, the phase was, what was the phase at 0? Solid and liquid. But when the temperature was changing from 27 degrees to 56 degrees, okay, that means that in this case, the water's liquid, in a liquid state. All right, so that means we need to do some thinking. We have to figure out why the temperature is not raising when there's two states of matter, but it's raising when there's one. So let's think about this and let's try to figure it out. Most of you got the idea that it takes energy to bring about a phase change. Many of you got the idea that as the ice melted, so it's changing into a liquid, it's in the process of solid, so some of it's solid and some of it's liquid, then the temperature remained constant. So in this spot right here, where what we call melting, where it has solid and a liquid, the temperature is constant. But when it's all liquid, the temperature is raising. Or if it's all solid, the temperature is raising. So what's happening? When the temperature is not raising during a phase change, what's happening to the energy? It's still being put in because my graph says right here that energy is increasing. So increasing energy, but no temperature change. What is going on? What is that energy being used for? That's the question. Energy is being used to melt the ice. Right here, it's being used to melt the ice. Remember that the shapes of a solid has a regular pattern, and liquid is a fluid and it flows. So it has some forces that are holding those molecules close together. Those forces have to be overcome to move it from one phase to another. And that is what the energy is being used for. Energy is being used to overcome those forces, to change its phase. I really hope this helps you. Like I said, many of you are so close, and I think you're getting it. You're going to have that aha moment. So fix up this lab, because you'll notice that there are a lot of questions on the Unit 2 test asking you about this graph. And understanding this graph will help you understand many, many graphs and also many concepts in science. You can do it. You're doing awesome. Way to keep up with it. Way to be persistent. If you have any questions, please email me. If you're having any trouble, come into office hours and help sessions so I can help you out. We'll see you next time.